All right, welcome everyone. We're gonna get into it. So thanks once again for coming on live, and for those who are going to go see the replay, we are going to start today on another list tutorial. I guess I don't know what 2D lists are, but we're gonna find out. All right, let's go.
In this tutorial, I'm going to talk to you guys about two-dimensional lists in Python. Two-dimensional lists are extremely powerful, and they have a lot of applications in data science and machine learning. Here's an example. In math, we have a concept called matrix, which is like a rectangular array of numbers. Let me show you. So, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a rectangular array of numbers. We have rows and columns. So this is a 3 by 3 matrix in math. Now we can model this in Python using a two-dimensional list. A two-dimensional list is a list where each item in that list is another list. So you want to define a matrix. We set it to a list. Each item in this list is going to be another list, and that list represents the items in each row. So the first item in our list is going to be another list, and in this list, we're going to have the values 1, 2, and 3. Now the second item in our matrix list. Once again, we have a list. This list represents the items in the second row. So 4, 5, and 6, and finally 7, 8, 9. So as you can see, we have a two-dimensional list. Each item in our outer list is another list. Okay? So this is how we can implement a matrix in Python. Now to access an individual item in our matrix, once again, we use square brackets. Let me delete this stuff. All right. So how do we access one here? Well, we start with our list. Then we add square brackets. First, we need to go and get the first item in this list, right? So we pass 0. Now this expression returns another list. That is the inner list. In this list, let's say we want to access the second item. So once again, we add square brackets and we pass 1. That is the index of 2 in this list, right? So if we print this on the terminal, we get 2. Okay, so using 2 square brackets, we can access individual items in our matrix. And also we can modify these values using this syntax. So before printing this, let's change it to 20. So matrix of 0 and 1, let's change it to 20 and then print it. There you go. It's modified. Now here we can also use nested loops to iterate over all the items in this matrix. Let me show you. So we start with a rows for row in matrix. So with this loop, we are iterating over our matrix list. In each iteration, row will contain one list, one item, okay? Now, here we need to use an inner loop. So we need to loop over this row, which is a list of items. We can type out for item in row, colon, and print item. Okay, so let's run this program. There you go. We get all the items in our list. Hey, I just wanted to make a quick announcement. In case you haven't seen my website yet, head over to codewithmosh.com. This is my coding school where you can find plenty of courses on web and mobile application development. In fact, recently I published a comprehensive Python course that goes way beyond this beginner's course on YouTube. And if you're serious about learning Python and getting a job, I highly encourage you to enroll in this course. Just like this tutorial, you can watch it anytime, anywhere, as many times as you want. And you will also receive a certificate of completion that you can add to your resume. And the course comes with a 30-day money-back guarantee. So if you're not happy, we give all your money back. No questions asked. The price for this course is $149, but the first 200 students can get it for only $15. So if you're interested, the link is below this video. Click the link and get started. In this tutorial, I'm going to talk to you guys about the list methods or list functions. These are the operations that we can perform on a list. So let's define a list of numbers. Here we pass a bunch of random numbers like 5, 2, 1, 7, and 4. Now, there are a number of things we can do with this list. We can add new items to it. We can remove existing items. We can check for the existence of an item. These are the operations that we can perform on a list. So when we type numbers dot, we can see all these functions, or more accurately, the methods that are available in our list objects. So we can call the append method to add a new item to this list. Let's say 13. Actually, no, it's not a good number. I'm joking. I'm not superstitious. So let's add 20. Doesn't really matter. And then print our list. When we run the program, you can see 20 is added at the end of this list. But what if you want to add a number somewhere in the middle or at the beginning of our list? For that, we use a different method that is called insert. So insert, now this method takes two values. Let me show you. So when we open parentheses, look at this little tooltip above the insert method. You see the first value that we need to pass here is an index. So this is the index at which we want to insert this new item. Let's say we want to add an item at the beginning of our list. So we pass the index position of 0, and then the second value is the actual object we want to add to this list. Let's say we want to add the number 10. Now, when we print this list, you can see that the number 10 is placed at the beginning of the list, and all the other items are pushed to the right. We can also remove an item, so we call remove and pass the item that we want to remove. Let's say we want to remove 5. Now we print our list, so you can see 5 is gone, and we have 2174. If you want to remove all the items in the list, you can call the clear method. So clear. This method doesn't take any values, so we simply call it, and it empties our list. All the items are removed. We also have another useful method called pop. And with this, we can remove the last item in a list. Let me show you. So run our program. You can see the number 4 is removed from the end of our list. Now, if you want to check for the existence of an item in a list, you can call the index method. So we call index and pass a value here like 5. And this returns the index of the first occurrence of this item. So let's print this on the terminal. We don't need this line anymore. So the index of 5 is 0. What if we pass a number that doesn't exist in this list? Let's say 50. Run the program. We get an error. We get a value error. 50 is not in the list. There is also another way to check for the existence of an item. We can use the in operator. So let me show you. We type out 50 in numbers. Earlier, we used the in operator with a string. We could check for the existence of a character or a sequence of characters in a string. Now here we're checking for the existence of 50 in the list of numbers. So let's print this. We get a Boolean value, false. So unlike the index method, this expression doesn't generate an error. So it's safer to use this. We also have another method for counting the occurrences of an item. Let's say we have another 5 over here. Now we can call numbers that count and pass 5. And this should return 2 because we have 2 5s in this list. Take a look. There you go. That is pretty useful. Now, if you want to sort your lists, you can call the sort method. So we call the sort method here. This method doesn't take any values. So look at the return value. That is none. None is an object in Python that represents the absence of a value. So this sort method doesn't really return any values. It simply sorts this list in place. So instead of printing the return value of this method, we simply call it to sort our list and then print our list. Take a look. Now all the items are sorted in ascending order. We can also sort the items in descending order. So after we sort the list, we can call the reverse method, and this simply reverses our list. Now let's go ahead and run our program. Take a look. Our numbers are sorted in descending order. And one last method I want to show you here that is pretty useful is the copy method. So copy. With this method, we can get a copy of our list. So let's define another variable called numbers2. Now, numbers2 is a copy of our original list. So if you make any changes to our original list, if you add new items to it, if you remove existing items, these operations are not going to impact our second list. Let me show you. So after we take a copy of our numbers list, let's add a new item to this list. So numbers.append 10. So the first list is updated. So now we have a new item in our first list. Then let's print the second list. Take a look. We don't have the number 10 here because these are two independent lists. So these are all the operations that we can perform on lists. We can add new items to a list. We can remove existing items. We can check for the existence of an item. We can sort our lists and copy them. Now here's the exercise for this tutorial. I want you to write a program to remove the duplicates in a list. Again, this is a fantastic exercise. So spend a few minutes on this and then come back, continue watching. All right, let's say we have a list of numbers with a bunch of duplicates. So 2, 2, 4, 6, 3, 4, 6, 1. We want to remove the duplicates.
All right. So let's see here. Start with your numbers. Two, 4, 6, 3, 4, 6, 1. All right, 2, 2, 4, 6, 3, 4, 6, 1. All right. All right, next.
So we need to define another list. Let's call that Unix. Initially, we set it to an empty list. Then we need to iterate over our first list, get each item, and if we don't have that number in this Unix list, then we'll add it to the second list. As simple as that. So for number in numbers, now we need to check to see if we have this number in the second list. So we use the in operator. If number not in Unix, so note that here we are using the not operator. So if we don't have this number in this Unix list, then we'll need to add it. So
All right, for number and numbers, if number not in Unix. All right.
So Unix.append number. That's all we have to do. So let's go ahead and print the Unix list.
All right. If number Unix, turn Unix.append number. All right. Print Unix. Right.
There you go. So we have 2, 4, 6, 3, and 1. The duplicates are removed. In this tutorial, I'm going to talk to you guys about another important structure in Python called tuple. Tuples are similar to lists, so we can use them to store a list of items. But unlike lists, we cannot modify them. We cannot add new items. We cannot remove existing items. We say tuples are immutable. We cannot mutate or change them. Let me show you. So I'm going to start by defining a list of numbers, 1, 2, 3. So we use square brackets to define lists and parentheses to define tuples. So if we change this to parentheses, 1, 2, 3. Now we have a tuple. So if we type numbers dot, look here, we don't have the append or insert methods. So we cannot add new items to this tuple. We also don't have remove, clear, and pop. We cannot remove any of these items here. We only have two methods, count and index. We use count to count the number of occurrences of an item, and index to find the index of the first occurrence of an item. So we can only get information about a tuple. We cannot change it. And by the way, these other methods that you see here, they start with two underscores. We refer to these as magic methods. They're more of an advanced topic, so they go beyond the scope of this tutorial. If you're interested to learn about them, you can get my Python course. I've covered them in detail. So similar to lists, we can access individual items using square brackets. So we can get the first item like this and then print it on the terminal. There you go. The first item is 1. But if we try to change the first item, we'll get an error. So numbers of 0, we set it to 10 and run our program. There you go. We get this type error because the tuple object does not support item assignment. So we cannot mutate or change tuples. They are immutable. Now, practically speaking, most of the time you'll be using lists, but tuples are also useful. If you want to create a list of items and you want to make sure that nowhere in your program you accidentally modify that list, then it's better to use a tuple. In this tutorial, I'm going to show you a powerful feature we have in Python called unpacking. So let's define a tuple called coordinates. And here we pass 3 values, 1, 2, 3. So imagine these are the coordinates for x, y, and z. Now let's say we want to get these values and use them in a few expressions, in a few complex expressions in our program. Maybe we want to include them as part of a large complex formula. So to get them, we'll have to write code like this, coordinates of 0. Then let's say we want to multiply this by coordinates of 1, and then multiply it by coordinates of 2. Our code is getting a little bit too long. This is just a very simple example. But let's say we want to use these values in quite a few places in our program. So a better approach is to get these values and store them in separate variables. Like we can get coordinates of 0 and store it in x. Then we get coordinates of 1 and store it in y. And similarly, we get coordinates of 2 and then store it in z. Now, instead of repeating coordinates of 2 or coordinates of 0 multiple times, we can simply work with these variables, x times y times z. That is better, right? So nothing new so far. But in Python, we have a powerful feature called unpacking. And with that, we can achieve the same result with far less code. So we can define our variables x, y, and z and set them to our tuple. What we have on line 6 is exactly identical to what we have on lines 2 to 4. So this is a shorthand to achieve the same result. So let me delete this and explain how this code works. When Python interpreter sees this statement, it will get the first item in this tuple and assign it to this variable. Then it will get the second item in this tuple and assign it to the second variable. And similarly, it will get the third item in this tuple and assign it to the third variable we have here. So we are unpacking this tuple into 3 variables. Now, if we print x, you can see x is 1. Similarly, y is 2. There you go. So this is unpacking. And by the way, this is not limited to tuples. We can use this feature with lists as well. So if I change parentheses to square brackets, now coordinates is a list. So we can unpack this list into 3 variables. Now, run our program, you can see y is 2. In this tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, email, phone number, address, and so on. Now, each of these attributes has a value. For example, the name can be John Smith. The email can be john@gmail.com. The phone can be whatever. So what we have here is a bunch of key value pairs. So in this example, our keys are name, email, and phone, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary in Python. Back to our program, I'm going to define a variable, customer, and here we set it to curly braces. With these curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs in between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30. Let's add another key value pair is underline verified. And we set this to a Boolean. Now, what matters here is that these keys should be unique. So if I add another key value pair here, let's set age to 40. Now look, PyCharm has highlighted the age key because we have duplicated that, and that's not allowed. So each key should be unique in a dictionary, just like the dictionaries we have in the real world. In a real dictionary, we have a bunch of words and their definition. Each word is listed only once in a dictionary. We don't have the word book twice. So let's delete this second duplicate key value pair. So the keys should be unique. And in this example, I'm using strings, but they can also be numbers. We're going to look at that later. But the value can be anything. It can be a string, a number, a Boolean, a list, literally anything. Now we can access each item in this dictionary using square brackets. So we type customer, square bracket, and then specify a key, like name. And this will return the value associated with the name key. Let's print it on the terminal, have a look. There you go. So the name is John Smith. Now, what if we pass a key that doesn't exist? Let's say birth date. Run the program. We get a key error because we don't have a key called birth date. Also, if we spell name with, let's say, a capital N, we get the same error because we don't have a key with the exact same sequence of characters in this dictionary. Now, to get around this, we can use the get method. Let me show you. So instead of using the square brackets, we call the get method and specify our key. Now, if we use a key that doesn't exist here, it doesn't yell at us. For example, if we pass birth date, it simply returns the none value. Earlier, I told you that none is an object that represents the absence of a value. So instead of getting a key error, we get none. Then we can also optionally supply a default value. For example, if this dictionary doesn't have this key, we can supply a default value. Let's say January 1st, 1980. Let's run the program. Now, instead of getting none, we get this default value. So this is how we can access the value associated with a key in a dictionary. We can also update these values. For example, before a print statement, we can write code like this. Customer of name. Let's update the name to Jack Smith. Now, this little warning here is telling us that we could simply put Jack Smith here instead of defining it once and then update it. Don't worry about that. It doesn't really matter. Now with this line, if we print the name of this customer, we should see Jack Smith. Let me show you. So I'm going to use the square bracket notation again. Let's print the name of the customer. You can see that is updated here. We can also add a new key here. Let's set the birth date to some value like January 1st, 1980. And then we can print it here. So as you see, we can easily add new key value pairs to a dictionary. So this is the basics of using dictionaries in Python. They're extremely important and they have a lot of applications in the real world. Okay, here's an exercise for you. So here we have this program that asks our phone number. Let's type 1234. We type it in digits, and then this will translate it to words. Take a look. Enter. It prints 1234. That's a pretty cool program. So go ahead and spend a few minutes on this exercise. That's pretty easy. I will see you next. All right, so first we need to get the user's phone number. We call the input function with the label phone. We get the result and store it in this variable. Now let's say the user enters
All right. At the first line. Okay.
1, 2, 3, 4. So we need to loop through this string, get each character, and translate it to a word. So what we need to implement this scenario is a dictionary, because a dictionary is a structure that allows us to map a key to a value. So we can have a dictionary with keys like 1, 2, 3, 4, and we map each of these keys to a word. So we can map the digit 1 to the word 1. We can map 2 to TWO. You got the point. So let's define a dictionary. We can call it digits underline mapping. Now in this dictionary, I'm going to add a few key value pairs. 1, we map it to 1, 2 to 2, 3 to 3, and finally 4 to 4. Now technically we should add.
Okay, so let's go there. So digits. Mapping. All right, so I'm going to start with 1. One colon, one double parentheses, comma, 2. Three.
Add all the digits from 0 to 9, but I don't want to waste your time typing repetitive things here. You got the point. So let's move on. Now we need to loop through the phone string. So for character in phone, we get each character and then use it to access a key value pair in our dictionary. So digits, underline mapping, we can use square brackets or call the get method. I would prefer to use the get method. So in case the user enters some character that is not part of our dictionary, our program is not going to yell at them.
All right.
So we call the get method and pass this character as the key. And if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word. Now we need to add this word to an output string. So we can define an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this. And
All right, so let's go back to line 8. Create an output string. Output, or characters of phone. All right, in front of digits, we're going to put output. All right.
And we should also add a space at the end. So
All right. Space plus space. Okay.
the words are not close to each other. Okay? That's all we have to do. Now, finally, let's print this output, run our program. So I'm going to type
Okay. So on 11, print output. All right, run. Okay, phone.
1, 3, 4, 5. Let's see what we get. We get 1, 3, 4 with an exclamation mark.
Okay, so you're gonna type in 1, 3, 4, 5. Okay, hit return. 1, 3, 4 exclamation mark. All right, so tomorrow, emoji converter. This should be cool. All right, so tomorrow we're going to be, I believe it's tutorial 9. And we're going to be doing emoji converters. I'm sure everybody knows what an emoji is. I think it's self-explanatory. I'm sure many have used emojis before, but we will start on that tomorrow. So everyone have a good day, and we'll see you tomorrow. Start tutorial. Yep, tutorial 9. All right. Take care.